I'm Michelle. I work on strategy for the CEO at Cerebras. We build the largest computer chip in the world, and it's purpose-built to accelerate AI workloads. What this means is that Cerebras 8 years ago taped out its first generation of the wafer scale engine. It's a chip that is this big. It's an entire piece of silicon. You clip off the ears and you have 900,000 cores on the chip. I'll go into this after this slide, but what it means for businesses today is that we solve fundamental business problems using this hardware that we designed from ground up to run AI workloads. And so this first part is Moore's law, which everyone has heard of. You shrink the transistor, but at some point, this law will go into the ether, but not quite yet. But right now, the way Cerebras differentiates from shrinking transistors for NVIDIA A100s, H100s is that we expand beyond that. Our key differentiator lies in both our chip and also our custom packaging around it that allows it to have power efficiency and power delivery to the chip that you cannot do on GPUs. So what does that mean? So this is a physical look on the chip. It's about this big. You can hold it. But it has 4 trillion transistors, 900,000 cores optimized for AI, and it's currently fabbed at the 5 nanometer process at TSMC. We package the chip in a custom way, which is done in California. And so what this means is the massive size of the wafer scale engine, it's not just big, it also allows you to have more memory. So we have 44 gigabytes of SRAM, which is 7,000 times more memory bandwidth than an NVIDIA H100 GPU. And so the combination of 900,000 AI cores and massive on-chip memory allows us to have an extraordinary performance for both AI training and also inference. And so what differentiates our architecture technologically from NVIDIA GPUs is this is basically where an H100 would play when you give it a big problem. And so our architecture allows us to scale vastly easier than GPUs. And so our ability to build big clusters and our ease of scaling allows users, developers, and businesses to come to us quickly to build AI models and to string together massive amounts of compute. And so this is for NVIDIA GPUs. You basically have to cut up the problem and redistribute it across GPUs. And so when that happens, your lines of code increase exponentially as you scale across hundreds of GPUs or thousands. And so as you scale up your model to a 70 billion parameter model, a trillion parameter model, your lines of code also increase. And so the differentiator here for Cerebras is that we built an AI chip in compute and memory in a way that eliminates the time-consuming problem of distributed compute and enables developer velocity. So today we're able to run enormous models on a single system. And so we can scale through data parallelism, which is quick and easy. And so there is no need for complex parallel programming, libraries like Megatron and DeepSpeed, or painful distributed programming. And so as a business, your developers, when they use our systems, they can focus on the AI and not the complex parallel programming. And as a result, they can start and scale their work much more quickly. Practically, what does this mean for your business? So I'm going to give 2 examples really quickly about how businesses have utilized Cerebras to drive actual value and outcomes within the business itself. And so Mayo Clinic is one of our partners. We recently announced their partnership earlier this year, and the story behind this is they came to us because Mayo has troves of data, and they have unstructured data, and that is their advantage. Their data is their advantage, but they wanted to leverage AI and try to drive that to have outcomes for their patients and their doctors. And so they came to us and we took their data, their EHR data, their medical imaging data, and we ran an internal request for proposals, which basically meant we asked the doctors, hey, what kind of problems would you like to solve using this data? And afterwards, our machine learning engineers went in and partnered with them hand by hand and figured out the top 2 proposals to start working off of. And so with our Mayo partnership, we basically use genetic and patient data to predict from genetics what is the right rheumatoid arthritis drug. That was one product. And then we also estimated a patient's time length in the emergency room. So these were the first 2 projects we piloted for Mayo. But the key point here is when an organization has proprietary data, they want to leverage that data to drive business outcome, because maybe there's a top-down mandate to have AI in your organization, because right now AI, there's a lot of hype around it. But how do you actually do that? You use compute, you have the data, and then you have the right people in the room who actually know how to get your models to converge. So a second example in the multilingual field is JACE. So our machine learning team consists of industry visionaries, people who have decades of experience in data engineering and large-scale AI model development. And so we pioneered models JACE 13 billion and 30 billion parameter models. That is one of the most accurate and premier English and Arabic model in the world. And we worked with one of our strategic partners, G42, to pioneer JACE. And so practically what this means for the world is that JACE enables a broader population of Arabic speakers to be able to work and engage with state-of-the-art LLMs. And we also have models in Spanish and Catalan. And so the key differentiator here is that when we built this model, Cerebras demonstrated 136x GPU throughput through a radical reduction in the final production model and its training time. And so our customer at first was trying to train this, and they spent about 68 days trying to train this. And we were able to train this in 2 days on 16 systems. So this is more of a slide to show what our business can do for your business if you're an enterprise customer sitting here. But we have customers in production using our wafer scale chips today. And these are large and small customers all across life sciences, energy, government, healthcare. We do business from everyone with the DoD, the Department of Defense, with DARPA, all the way through the Mayo Clinic, GlaxoSmithKline, and also to energy and oil companies as well. And so Cerebras is positioned as a unique one-stop shop that provides both compute, machine learning expertise, and if you have data and you want to drive business outcome from your data, we are here to help and deliver you that model. One part that's not on this slide that I would also like to touch quickly upon is I think when we think about AI, it's not just the applications that we're thinking about, it's also compute, data, and algorithms. And I think one thing that for compute that people often forget about is compute governance matters. When we talk about AI regulation, it's not just about regulation for the benchmarks, the foundation models. Compute governance, who has access to this hardware, who is paying money, who is funding and buying more GPUs also matters, because that's the base core infrastructure layer. So I would end this talk on one note, which is as we think about developing models, I think we should also think more critically and thoughtfully around compute, AI compute governance, and also seeing where the money and the energy has shifted globally and geopolitically around this. And I think that's a key area to focus on as well. But thank you guys.